is about exponential base e. E is a special number. It's sort of like pi. It's one of the constants in mathematics that mathematicians have discovered over the many years. This one's been known for a couple centuries. Various definitions. Basically, it arises from continuous compounding. I'll get to that later. At which it directly leads to this. E equals a limit as n goes to infinity of 1 plus 1 over n to the nth power. This 1 over n means it's approaching 1, so 1 to the n is 1. But on the other hand, n is approaching infinity, and something to infinity, something bigger than 1 to infinity is infinity. So it's being tugged in two directions, towards 1 and towards infinity. Now, its value, if you actually start trying to take limits for the values of this for various values n, you get something increasingly close to 2.7182818284590 and on and on and on. It goes on infinitely many places, never repeating because it's not a ratio of integers. Another way to write it is by what's called a continued series. Infinite series. 1 plus 1 over 1 plus 1 over 1 times 2 plus 1 over 1 times 2 times 3 plus 1 over 1 times 2 times 3 plus times 4, and so on forever. These denominators get ever bigger, the fractions get ever smaller. These add up, these additions accumulate to a finite amount, roughly this, and equals this in precision. Okay. This should remind you of part of the continued, the compound interest formula, because it's derived from it. And continuous compounding is what happens if you allow the number of compoundings per year to approach infinity. So it's compounding all the time. It's like before. The P is a present value, A is a later value, R is the interest rate, T is time then. A equals P times E to the RT is the formula. So for example, principal of $5,000 with an interest rate at 8.2% compounding continuously for 12 years yields what future value? Okay, the value is P is A, which is P e to the RT. That's 5,000 times e to the 0.082 times 12. After some calculation, that's $13,375.68. Almost a tripling of value in the 12 years. All right, here we have an exponential decay. Some amount of money or whatever is slowly fading away. Starts out as 15,895. It decays at 2% per year. It's depreciating, I dare say. For 16 years, for what value? Well, P e to the RT. P is 15,895. R is negative 0.02. T is 16. So this multiplies out to 11,542 and 14 cents. So it's lost a bit more than $4,000 in that time. Here we have a $565 principal, depreciating at 0.5% per year for 8 years, yields what? All right, 565 is P e to the negative 0.005 is R times 8 per years, comes out to $542.85. So it's about $20 less. If P at T is 2 times e to the 0.02t, then what is P at 12? So it starts at 2 at time 0. It's 27% interest rate for 12 years grows to what? Well, 2 times e to the 0.27 times 12, after a bit of calculation, is about 51. Okay,